About a year ago, an American artificial intelligence company, OpenAI, unveiled ChatGPT to the world, an AI chatbot that disrupted the public's perception on the capabilities of AI. The program allows people to ask questions to which they get a detailed response that is mostly accurate. This, alongside many other AI programs, became very popular very quickly. Almost all of them are built on deep learning algorithms called artificial neural networks. But what is an artificial neural network? How does it work? And why is it so crucial to the development of AI? Before explaining the artificial neural network, it is essential to have a basic understanding of AI and its subfields, including machine learning and deep learning. Artificial intelligence is a broad term used to define systems or machines that can mimic human-like intelligence. They are mainly categorized into three types. Artificial narrow intelligence refers to AI that is capable of performing only particular tasks but lacks the capacity to learn independently. Artificial general intelligence refers to AI that can think, learn, and perform anything similar to humans. Lastly, artificial superintelligence refers to AI that can surpass all capabilities and knowledge of humans. At present, we have artificial narrow intelligence with research underway in the realm of artificial general intelligence. Under the umbrella of AI, there is the concept of machine learning. Machine learning uses statistical learning algorithms to build systems that can learn automatically. It learns information directly from processed data, allowing it to uncover insights and make predictions. Machine learning is further categorized into two types. In supervised learning, the machine learning algorithm is trained on input data labeled with the right answers. So when the machine makes a mistake, it can cross-check with the right answer. In unsupervised learning, however, the algorithm is trained on unlabeled data with no predefined answers. So the machine has to learn through trial and error, which tends to be a significantly slower process. Traditional machine learning methods can struggle with complex and large data sets, but that is where deep learning comes in. Deep learning is a subset of machine learning and is capable of handling extensive complex data that does not necessarily require large data to be pre-processed. For example, if a deep learning algorithm is shown images of pets, it will determine features like ears, nose, etc. on its own and will then predict the outcome. One of the most commonly used deep learning algorithms today is the neural network. First proposed in 1943, artificial neural networks were developed to mimic the neural network of our biological brain. Our brain contains more than 80 billion neurons that are connected in a net-like structure, and every single one of these neurons is capable of carrying information via small electrical pulses. Every time you learn something, a new connection is formed, or an already established connection between these neurons gets strengthened. The neurons of an artificial neural network are called nodes. In any artificial neural network, or simply neural network, there are at least three layers of these nodes: the input layer, the output layer, and the hidden layer. A neural network model receives data from the input layer, processes it in the hidden layer, and predicts the outcome for the output layer. Most of the models contain more than one hidden layer, because when a task is complex, more layers in the middle are required to perform complex operations. One of the neural network models, known as large language models or LLMs in short, is the foundation being used today for programs like ChatGPT. Apart from these programs, neural network is used in search engines, social media algorithms, medical diagnosis, speech recognition, you name it, almost everywhere. So how does it work? Let's take a simple example. Suppose we want to build a neural network that predicts whether the fruit is going to be an apple or a banana based on its size and color. For the network to predict the fruit accurately, it must undergo training. Our network will have one input layer with two nodes for size and color, one hidden layer with one node for processing, and one output layer with two nodes for outcome, one for apple and one for banana. Now every connection between these nodes has a value assigned to them called weights. Weights determine how much importance should be given to a connection between two nodes. They determine the strength of a connection. Each node within output and hidden layer itself has a value assigned to them called bias. Think of it as the node's personal preference, a bias that influences the final decision-making process. Initially, the network's weights and biases are set to random values. During training, we feed the network with values of the size and color of a fruit. The network computes these values in the hidden layer with weights and biases. It sends the computed answer to the output layer nodes where the final value is determined. If the value in the apple node is greater than the banana node, it means that the network predicts the fruit to be an apple. Vice versa if the value is greater on the banana node. After going through the training process repeatedly, the network will start to learn and adjust its weights and biases to help predict the outcome better and better. Neural networks allowed programs like ChatGPT, Microsoft Bing, and DALL-E to develop. Although one of the common criticisms of neural networks is that they require a large variety of training data to function effectively. Recently, GPUs have become the preferred hardware as they can handle complex and massive amounts of data. However, having many of these GPUs to train models quickly adds up to the costs as well. AI applications are such part of our daily lives that we don't even recognize what is happening in the background while using the technology built upon it. Since 2010, many major companies like Google, YouTube, Netflix, Amazon were already using applications of AI. According to the IBM Global AI Adoption Index of 2022, reportedly 35% of companies in the world were already using AI in some capacity in their businesses. As methods, computations, and tools become increasingly advanced and sophisticated, the growing prevalence of AI in our daily lives becomes increasingly apparent. It remains to be seen if we will ever reach a point of singularity, the point at which the AI evolves itself to such a level where comprehending or even predicting its intelligence becomes impossible for humans. Perhaps it is not a question of if, but when. If you would like to see more of this, be sure to check out our previous videos and remember to subscribe. Hit the bell icon to stay notified of upcoming videos. If you have some future video suggestions, comment down below.